It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson.
Welcome everyone to another episode of Pure Performance. I know normally you expect the voice of Mr. Brian Wilson, who does a much better job in doing the initial intro. I'm pretty sure as he has been always going to post-process the whole thing, he will come up with a great intro music or something to make me sound funny in the end. But I'm here today without Brian because he's part of a training. And that's why I have the honor to interview and talk with Stefano Doni, completely to myself. Stefano, I have you for myself for however long this will take. But thanks for accepting this invitation. First, for the people that have not heard or seen you before, who are you and what makes you excited about performance?
Hi, everybody, and thanks, Andy, for having me today. I'm really excited to be here. Well, basically, just a quick intro about myself. I'm Stefano Doni. I'm co-founder and CTO at Akamas. So really, my background is mainly on performance work. So I started off doing capacity planning and optimization work about 16 years ago. So my first exposure was to performance was actually to build mathematical models to predict capacity of enterprise systems like servers, storage, and network, etc. Then I gradually moved to product position where I focus on trying to create new solutions to solve hard performance engineering problems in a better way, in a sense. And that brings me to Akamas, which is a company that I co-founded in 2019, which is about solving performance optimization problems in a completely new way using artificial intelligence.
That's great. And first of all, I have to go a little back to a different topic. It's clear for most, based on your name, that you're Italian. And I have to congratulate you and your nation again to the great victory. And of course, it was the Austrians that let you pass to the last rounds, because we thought in the end, Italy is definitely a better Eurocup leader than we. That's why we are gradually. This is just a little side joke because Brian and I have been talking about the Eurocup in the last couple of episodes. But seriously, I'm really happy to have you, I think, again on one of my channels, because we talked about Akamas in previous episodes, in webinars. I really like that you are really also helping us on the open source side with Captain to bring all of these performance optimization use cases to the community. You just made me aware of that you have explore.akamas.io, which is a code lab environment where people can explore Akamas. So we'll definitely make sure to link. As I'm looking at it right now, if somebody now, let's say, goes to explore.akamas.io, what's the best kind of tutorial to get started with?
Yes, I guess the initial one is great, which is the welcome tutorial, which is about really 2-minute video where you can get a sense of what Akamas actually do.
Yeah.
Then we have actually tutorials to optimize Java applications. So I guess we touched on this towards the end, but we recently launched the free trial initiative at Akamas. So you will actually have the possibility, and lots of performance engineers are actually signing up this month to try Akamas out, even on your laptop. You can install it locally and try out the first guide to optimize the Java performance and see actually what we will be talking about this kind of Java performance tuning myth on your actual laptop.
Yeah, and that brings me now, let's jump into the topic, because I told you it's really great when you suggested the episode on 4 Java tuning myths. And people are always excited about things like things that break or things that they thought they know about things. I think myths is another big topic. So let's go, kind of step by step, because I know we have a lot of Java performance enthusiasts as listeners. So let's talk one by one. What's the first myth?
Okay, great. So the first myth is about tuning the JVM garbage collection performance actually lead to faster applications.
That's a myth. I thought that's a given fact.
Yes, actually, that's an interesting piece, actually.
Yeah.
So this myth, it's actually, if you're into JVM tuning, and I know lots of listeners are actually hardcore JVM tuners or actually Java performance lovers, you know that actually the main target of tuning the JVM is actually the garbage collector. So the garbage collection is actually the process within the JVM that basically manages the memory. So the main feature is to free up memory that the Java program, the Java application actually allocates in a way that in such a way that the application developer actually doesn't need to care about memory management. It's one of the biggest benefits of the JVM. But everybody knows that the JVM is also one of the biggest performance problems. The GC, sorry, is also one of the biggest performance problems of the JVM itself. So there are really countless of blog posts and entries and tuning guides and rule of thumbs about how to tune the garbage collector over the years, even by the community, by even high-profile organization, etc. Mm-hmm. And really, if you look at, there's really a pattern across all those guides, which is actually this first golden rule, as we call them, of garbage collection performance, which is actually basically also stated by Oracle itself in the tutorials about garbage collection tuning. And this actually rule states that you really need to lower the garbage collection time, the garbage collection overhead, in order to make your application run faster. So let me briefly describe what it actually means. So if you know the garbage collection, how it works, it basically has this task of freeing up the memory. And in doing that, it basically needs to stop the application threads. So you will have this pause time or stop the word pause or suspension time. Actually, various tools call them in different ways, where your application threads are completely stopped in waiting for the garbage collection to do its work. So the rule states basically that you need to decrease the amount of time the garbage collection actually stops the application. Mm-hmm. So if you think about it, actually it makes totally sense. So if we decrease the garbage collection time, we will get higher application throughput, higher application performance, because actually the application threads can run for more time without being stopped.
Mm-hmm. Yeah, makes sense for me.
Okay. The interesting thing is that at Akamas, actually, tuning the JVM is one of the main targets because lots of enterprise and also cloud-native applications today are built on using the JVM. So we have pretty interesting experience in using AI to explore the effects of tuning the different JVM parameters. So today, a JVM has more than 800 parameters that you can tune. Actually, it's very, very complex for the human brain to do that. And by looking at the results that Akamas achieved by tuning this lots and lots of JVMs, we came to realize, actually, and we were basically also ourselves very surprised that if you tune the JVM to lower the garbage collection time, which is basically what everybody is doing, you may actually end up by slowing down your application.
How does that work?
Instead of making them run faster.
Yeah, but why?
Why is that? So let me tell you the story. So basically, we did lots of experiments. In this case, by the way, we have published the results, the complete results, also in a recent blog post. We did an experiment on a Java 11 application using OpenJDK 11, varying all those JVM parameters with the Akamas, and then we executed the Java application. It was a Spark application. And then we measure the performance that Spark job actually took with the different kind of JVM settings. And after this optimization study, actually, what we got was a striking result. So we have looked at the best JVM settings that Akamas found, so the ones that made the application run faster. And the first interesting thing is that we noticed that the best JVM configuration was actually able to make the application run 30% faster than the baseline. So which is already great, meaning that you have this kind of, in a way, space of potential exploration and potential performance improvement going past the default values that today's JVMs, in a way, have built in. But what it is striking is actually what happened to the garbage collection overhead during those optimization. So the configuration that had the higher performance actually also had higher garbage collection overhead with respect to the baseline. So this is a completely, in a way, counterintuitive result because actually it's literally counterintuitive and the opposite of what we might have expected. So how can it be that if we, in a way, let the garbage collection stop for a greater amount of time, our application, the end-to-end application performance will actually improve. So that was also, in a way, counterintuitive that we needed absolutely, in a way, understand also ourselves being performance engineers, what is happening, what was happening under the hood. So we dug deeper on this issue. And in order to do that, we have done some deeper performance analysis using on the Linux kernel level. So what we did was to actually trace the CPU scheduler, which is actually basically a key component of the Linux OS that actually has to decide where to schedule the different application threads onto which CPU. There are lots of open source tools to do that. For the most famous one is Linux Perf, which lets you do this. We used a tool that is called Perfecto, which is made by Google, and it's actually open source. And it's interesting because it's a tool used by Android application developers in order to understand the behavior of the Android system. For example, when you have performance glitches on your mobile apps. But it's interesting because it basically runs on every Linux OS. So we use that to actually understand how the different threads within the JVM were scheduled onto the virtual machine CPUs, basically, in order to understand how the things actually were being scheduled. And what we understood was pretty striking results, which is actually one of the explanations for this, in a way, counterintuitive result that we are talking about. So the first thing that we notice is that the garbage collection actually that is being used in JDK 11 is the so-called G1 GC, and the G1 GC has been designed in a way to reduce the application pauses. So it's a GC that by default tries to minimize the amount of time it stops the application. And in order to do that, actually the design feature of G1 GC is that it has some threads that actually can clean up memory while the application is running. Mm-hmm. So those are called concurrent GC threads. So the G1 GC tries to freeze up and, in a way, do some memory reclamation activities as the application is running. And then, of course, at some point, it needs to stop the application. So there are other threads for the G1 GC that are called parallel threads that actually do the cleaning work when the application is actually stopped. And the key, in a way, insight that we got by looking at how those threads are actually running with respect to the application threads, we noticed that actually the concurrent threads of the G1 GC was actually competing with the application threads. Mm-hmm. So they were running concurrently, and in a way, they were stealing CPU cycles from the actual application threads. So in a way, they were making the application run slower, even in the baseline. Mm-hmm. And why the G1 GC actually does that? Because by design, it wants to minimize the actual pause. So the JVM configuration that Akamas found was a configuration that actually minimized, when we look at it, the work of those concurrent threads, which is something that let the application actually run faster for most of the time at the expense of higher application pauses. Mm-hmm. So this kind of, in a way, counterintuitive result actually made the application, the overall end-to-end application run faster. And the insight here is that really why the golden rule doesn't work anymore, because actually this work of the G1 GC concurrent threads is not really counted as suspension time. Mm-hmm. Because actually they are really not suspending the application in a way that, as we defined before. But nonetheless, they are still, in a way, interfering with application performance because they are scheduled at the same time. So even though you might see from your tools lower garbage collection suspension time, this doesn't mean that garbage collection is not actually impacting your overall application performance.
Yeah, and that also means that a good performance engineer needs to look beyond the boundaries of your runtime, because in this case, you also need to look down to what the OS level, the kernel, what happens down there, right? Because in the end, these threads are executed on the OS level. And then if you only focus on what you see from what you think you know, then you may look at at wrong data and then make wrong assumptions and then optimize in the wrong place. That is really interesting. Wow, cool. Yeah. So that means it's on the one side, right? I guess for many use cases, it still holds true that tuning the JVM garbage collector leads to performance gains, but it's still a myth that this is true for every use case. So that is very fascinating.
Yeah, I think so. Actually, it's a little bit of sad news for the performance engineer, because actually those kind of rules are actually performance model that that let us think clearly about performance, let us reason about performance, let us actually understand where we need to focus our tuning effort. So it's a little bit sad news when performance models suddenly we realize that they don't work anymore. But I think nonetheless, it is important to recognize those facts. And it's really not a JVM fault here. It's actually, there are lots of other languages that have garbage collector, but basically the same thing can happen at the container level with Kubernetes. It can happen on the OS level. So basically the thing to realize is that our environments are actually more complex. And the thing is, we have less, in a way, insights as performance engineer to guide tuning as when these kind of rules doesn't work anymore. But we need to be, in a way, to be forced to look more on the end-to-end application performance. And of course, automating all these kind of tasks is actually one of the best way to move forward as a performance engineer.
Awesome. So this was fact number one. What about the next one? What's the next myth or insight?
Yeah, the next insight is actually also interesting because we call it the JVM short blanket in a way. Okay. So another well-known fact about the JVM performance is that there are some inherent, in a way, design trade-off within the JVM. It's actually, if you think about it, it's actually even more general than the JVM. But let's focus on the JVM. So you have this so-called performance triangle, meaning that you have three key performance indicators in a Java application that are throughput, latency, and footprint. Throughput, of course, means how many, in a way, operations can I do in a given amount of time. Latency is, of course, the amount of time it takes to do one single operation. Footprint is basically how much resources do I need, CPU and memory. So there's, again, the rules of performance of the JVM, which is pretty well known also in different conferences where even Oracle Performance Leader actually put it very clearly, is that if you think about those three KPIs, throughput, latency, and footprint, you can really get two of them. So you cannot at the same time improve throughput, you decrease latency and decrease footprint. This would be like the dream for a performance engineer, in a way, instantly make the application run faster, being able to process more work and cost less. Of course, that's the goal, but it's actually, there are actually some inherent design, in a way, issues, design properties that actually make reaching this goal very difficult without some significant development work. That's more or less the short blank that as we call it. So again, it completely makes sense also from a performance engineering point of view. I guess we are pretty used to reason about those terms and the fact that you cannot really take an application and improve all the three KPIs. And again, we have an interesting fact here because we use Akamas. That's a study that we did recently for our telco customer. And we got a very recently result by optimizing their CRM system that was again based on Java. I guess it was OpenJDK 9. And we use, again, Akamas to find out a JVM configuration that actually minimized the footprint, in this case, the memory, which was the bottleneck for them, while still keeping the performance level that they had before. So again, in a way, you want to make the application cost less because you want to reduce the infrastructure, but of course, you don't want to sacrifice latency or throughput. And when we analyze the results, so Akamas actually was able to achieve pretty significant result of reducing the heap size by 80% or so. But the configuration that actually was able to reduce the heap size to 80% also managed to improve the throughput and the latency by more or less 20% at the same time.
And is this because I assume less memory, less footprint also means less garbage collection in the end, or is that the reason, or what's the?
Yeah, again, that's interesting. So we this was a customer application, so we couldn't reproduce it locally and study it more. But actually, the trade-off, the typical, in a way, again, rule of thumb is that, of course, you can let the garbage collection run better by assigning more memory. That's again the typical suggestion. But some cases actually this can have some drawbacks because you will incur higher garbage collection times. Again, this is a kind of experiment that you need to do because it can be different from application to application, to workload. And again, it's interesting because typically you need to do significant development work, as the expert says, to improve all the three KPIs. But if you are able, like we did with Akamas, to explore this huge optimization space with 800 parameters, etc., you will actually be able to find configurations, specific configuration for your application that perhaps can give you, in a way, free lunch.
Yeah, and I think that this is a very important point that you just make. Every application is different based on the memory behavior, based on performance behavior, and this is why there's no rule of thumb that these are the perfect settings for a JVM. It always has to be evaluated, assessed, and optimized based on an application, but I guess also based on a particular load pattern, right, that an application has. Because an application that sits idle or doesn't do a whole lot behaves differently than one that is under heavy load. And so this is why I completely agree with you. It's so important to constantly, analyze and then optimize based on current load patterns. The best way, continuously, fully automated, right? But we'll get to more of this later on. So this was myth number 2. That means you just told me that you can escape the golden triangle of throughput, latency, and footprint and optimize all 3 of them. It's not that you can only pick 2. The next myth, and I want to also read it out loud for you this time, because thankfully you gave me all of these myths that we talk about. And this is one that I'm also kind of wondering. Why in 2021 do we still need to tune the JVM and not just let the JVM do its job, because the JVM itself should be smart enough?
Yeah, that's great. And actually, we have this myth. Actually, in all fairness, of course, the JVM itself and the OpenJDK developers are actually improving the JVM over time. So there are lots of work that is being constantly done to improve performance, improve garbage collection, reduce impulse time. So I don't want to pick on the JVM developers here. But the interesting thing is that we need to consider the JVM performance in a more broader context, which includes again your particular execution environments and also your performance goals. And those may not match what are the default JVM performance goals that comes out of the box. So in order to, I have 2 actually interesting data points here that I want to share. So the first one is a very simple performance experiment that everybody can basically replicate. We used Renaissance, which is a very popular open source Java benchmark. It's actually a suite that comprises about more than 20 applications. And it's being used by the Oracle and OpenJDK developer themselves as part of their benchmarking activities to understand if the JVM is improving and on which workload, and etc. So in this case, we took this benchmark suite and we did a very simple experiment. So we used, again, OpenJDK 11, and we ran a benchmark with an increasing amount of heap size. So we started off from 1 gig and in a 1 gig increment up to 5 gig. We didn't change any parameter here other than the maximum heap size. So again, this means that we are again getting the JVM GC garbage collector, which is the default one. What is interesting is that in the we recorded during this experiment, basically the major performance KPIs of the JVM, like the garbage collection time, the CPU utilization, and also the amount of memory that the whole JVM process actually used during the benchmark execution. And when we analyzed, actually, we found something very interesting. So what we noticed is that in the addition configuration with the 1 gig experiment, basically the garbage collection time was pretty interesting already, so pretty high. It was about 20%. But when we increased the memory, we assigned more memory in the subsequent experiment, 2 gig, 3 gig, up to 5 gig. We noticed that this garbage collection time actually did not decrease that much. It was already, in a way, an initial surprising fact, because actually, again, when you have JVM memory stress, the usual reaction is let's add more memory. The second thing that we noticed is that we recorded also the GC logs, and we analyzed how the different actual allocation patterns and the actual memory utilization was during the run. And what we discovered was that actually G1 GC with the default settings didn't actually use all the memory that we assigned. Mm-hmm. So, for example, out of 5 gig, we have the data that we will publishing as a next blog post also. It was actually using a little bit more than 3 gig. So that's very interesting to reflect a little bit on this result, because in this what is actually is that basically the garbage collection as a trade-off. The JVM itself has to decide many things. In this case, the G1 GC needed to decided actually to trade off to save memory, because actually it didn't decide to allocate the full 5 gig that was available, but instead to, in a way, spend more on doing garbage collection and also spend more CPU cycles in doing that. So again, that is interesting, because the takeaway I get from the performance engineer, and that is of course just one of the tunable, which is the garbage collection kind that you have on the JVM. Actually, JVM itself has to decide those kind of things. So actually, your performance goals might be different, because perhaps we might want to have, I don't know, lower CPU cycles, for example. So we might want to fully use the memory out of the box and smaller poses.
And which just basically means that, as you said earlier, and as we said earlier, a runtime, whether it's a JVM or any other runtime, right, is basically optimized by default for a certain scenario. And as you said, while these other developers are doing a great job to, I think, provide better runtimes out of the box for many use cases, it's impossible for the runtime developers to provide something that always works in an optimal way for your application, for your load behavior. But I think this is what you just added. What is your ultimate performance goal? And the performance goal could be throughput, latency, CPU consumption, memory, whatever it is, right? So that means the kind of a goal-driven optimization is something that is great, but a JVM developer, or there are many JVM developers out there that focus on performance, don't really know what is your particular goal, and therefore they cannot just deliver an out-of-the-box experience that works for you. Yeah, that makes a lot of sense.
Yeah, that's a great summary. Also, what is you mentioned it, of course. We don't want to pick on the JVM developers. Actually, I think JVM is actually the best runtime as it comes from performance and observability out there, because you can really inspect everything that is happening and you can get these kind of insights. I'm sure that those kind of, in a way, aspects also exist with other runtimes. But what is interesting is that also, if you think about the first myth, the thing is that JVM can only think about their own internal metrics.
Yeah, of course.
Not only they don't know your goal, but actually they cannot happen, for example, what is happening on the broader, I don't know, container level resources, or on the actual application performance, which might mean, I don't know, your 99 percentiles of your payments. Of course, there are layers in the stack.
Exactly.
JVM can only reason about their own internal metrics and actually auto-adjust in some cases with respect to their own metrics, but they cannot really understand and cannot really see what is your goal, and with respect to other business level, application level metrics that actually are far higher in the stack.
Yeah. Great. So that makes it 3 myths already. What's the last one that we want to talk about today?
Okay, the last one is actually what we called the cargo culting JVM tuning, or actually copying and pasting JVM settings across different applications. That is something that it's funny, but it's something that doing lots of those kind of exercises for in our customers, actually we see actually due to this complexity of tuning the JVM, developers tend to actually stick to, in a way, good configuration that are apparently good for a given amount of application, and then basically they suddenly it becomes their own best practice to configure the JVM for every kind of application. So this, of course, it's not really good because, as we have said before, every application is different. By the way, you may have JVMs for different versions also. And we have also different execution environment. We may have containers. We may have different goals, different workloads. So actually, this practice really has to be avoided. But we can understand because actually, due to the complexity of the JVM, people might be tempted to do that. In this particular, in a way, myth, actually, those are more actual misconceptions that we have found. 2 particular ones that I wanted to mention here is about actually garbage collection tuning. Again, we talked about the GC threads in the first myth and the fact that you may have concurrent threads, you may have parallel threads. The good news is that all those kind of threads are also tunables. And people have come up, the funny thing is that we have noticed that people have come up with various theories about how to best set the number of threads. If you think, for example, in container environments where you have Kubernetes resource requests and limits specified for your container, how many threads you want to allocate? So here we see different, again, theories, and sometimes we see people, in a way, coming up with funny ways to specify threads. For example, let's just put half of my container threads into the GC threads, because in this way I will leave the more in a way CPU cycle to the application. Well, again, in theory, it might sound like a good idea, but in the end, the JVM is complex, and doing that you might actually limiting, for example, the number of threads also for the parallel phases, which is the pause time. So by doing this kind of tuning, in a way, manual tuning, you might actually end up increasing your suspension time, which is pretty opposite with respect to your original goal.
This is it. I mean, in the end, all these 4 myths, right? They come down to, at least for me, something very obvious. And the obvious thing is that you need to tune your app on your specific runtime in your specific environment for your specific goals and throughput, because that's the only way you can truly say the application runs within the expected, let's say, classical performance behavior, which means throughput and response time, but also within, let's say, maybe your resource budgets that you have, whether it's memory or CPU. But it's always very specific. And as also applications change from build to build, from version to version, you need to, I guess, continuously do this type of optimization. And this is why, and now, hooray, obviously, right? You are working for Akamas, and you not just talk about these things because you do this manually on a day-to-day basis, but you've built a whole product around it. And this is just fascinating. And a product that can be fully automated, and that is then using insights from different observability platforms like Dynatrace, for instance, exactly, to really then make decisions. So this is really, really, really phenomenal.
Yeah, thanks for the summary. It was great. Actually, we have come from this kind of background in tuning the JVMs, in tuning. By the way, it's not just the JVM problems. It's something that it's more widespread. Pretty much any technology has this kind of issues. So also other runtimes, databases, Kubernetes containers, operating system, the cloud itself. So basically, this actually happen pretty much across the board in the stack of modern applications. So our approach is actually using artificial intelligence in a smarter way, also for automating the performance tuning of all those parameters in a way that on one side it's automated, so you don't need to be a JVM expert, as this may actually turn out being counterintuitive, that just following the rules or actually trying out by yourself some particular parameters. So we have already included in our product, for example, the knowledge of what are the most important JVM parameters, so that you don't need to do them.
Yeah.
And the second thing, which is very core, which is very important, is that of course we use artificial intelligence to actually understand what are the best settings and actually explore this very vast optimization space for you in a completely automated way. So performance engineers are actually loving the approach due to the fact that it allows you to reduce the time, basically, that is needed to do the tuning. But more importantly, if you think about the myth, what is actually very, very true for a performance engineer is that if you cannot rely anymore on those rules, what you actually are going to do, because if you just see the garbage collection that is high, you don't know anymore what you are really going to do without looking at the actual application performance, end-to-end application performance. So the thing is that Akamas is goal-driven, meaning that you can say, actually, let's optimize my goal, which might be my 99 percentile. Let's forget about all the JVM metrics. Of course, you can still analyze them because it's important to understand what is happening. But the key thing is that AI is actually driven by the goal that you can specify, which may be application metrics. Yeah. And that is one of the biggest value.
Yeah. Hey, Stefano, thank you so much for walking us through it. I know there's a lot of material on this topic already out there. I think you already gave some presentations at other conferences. By the time this show airs, I'm sure there will be even more content. People should look at your website, akamas.io. Again, explore.akamas.io. Great tutorials to walk through videos. And obviously Akamas Labs on Twitter. Anything else that people should be aware of? Any other ways to get in touch with you?
I guess one of the major news in this year was the actual launch of the Akamas free trial. So we had a lot of market requests to actually try out the product in a kind of self-service fashion. So actually we launched this new go-to-market model actually end of May, so it's pretty new. So you have now the possibility to actually try out actually what we are talking about today, because with the free trial you will get the possibility to actually download Akamas, the full product, and even install on your laptop. And this setup that we call Akamas in a box, we got inspired by Captain, the great work that you did there. And the interesting thing is that we also included into this box not only the product, but also a sample Java application. Again, the Renaissance benchmark that I was mentioning before, so that in a couple of steps, you can actually use Akamas AI and optimize the JVM performance and experience this new performance engineering way to do optimization in a couple of very quickly. So you can actually see what we are talking about today and analyze the JVM performance and get a sense of how the new approach can bring you the benefit as performance engineers.
Perfect. So with this, again, recap, if you're still listening and you're a performance geek, if you want to optimize performance, you've learned 4 performance myths. First of all, I really like that not always does tuning the GC lead to faster applications. The second one was the trade-off, the triangle, the golden triangle between throughput, latency, and throughput. Sometimes you don't have to only choose 2. Sometimes you can even choose 3, as you have proved. While the JVM in 2021 has been amazing, it's a lot of improvements went in. Still, you need to optimize for your own application. It cannot just figure out everything yourself, especially if you have certain performance goals. And then also the copy pasting from one setting to other applications comes back to, while it might be a good start, every application is different, and therefore do application-specific tuning, workload-specific tuning, but also environment-specific tuning, because every environment is also different, as we have learned, whether you run on bare metal or in the Kubernetes world on a virtual provider somewhere in the cloud, everything feels different. And with Akamas is a great product now also available in a box for every developer to try out themselves. So check this out. Stefano, again, congratulations to Italy and winning the Euro Cup. I'm pretty sure you will do amazingly well also next year at the World Cup. And looking forward to finally, after so many months, seeing you at some point at some event in person.
Yeah. Thanks a lot, Andy, for the nice word. By the way, it was a great match with Austria. It was very tough.
Yeah.
I really enjoyed it. So congratulations on you also.
Thank you. Okay, with this, we say goodbye to the listeners. Also, goodbye to Brian. I'm so sorry that you couldn't be here today, but he had a workshop to attend, but he will be back the next time. But still, thanks for making this show possible, because he's doing all the post-production, even though he's not here with us today. With that, all the best. Bye-bye. Ciao. 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 Ciao.